So, welcome everybody to the round table. We're closing the day slowly but surely. Let's see who we have here. So we're talking to Matthias Brendel. Matthias, there we go, there's Matthias. Vice President of the Business Field Electrification at AVL. Matthias studied mechanical engineering at the Technical University in Darmstadt, Germany. Started his career at GM Europe, Opel, Rüsselsheim. I've been there, nice place, in 1995. And he held several positions in the area of fuel cell development, battery systems, electrical systems, and safety and interior. So that's just about everything. You could go and work in a microfactory. You know everything. And you've been Vice President of AVL for Electrification since 2017. We also have next to me Horst Pflügl, Global Research Program Management. Horst studied electrical and automation engineering at the Technical University of Graz. His focus at AVL for 15 years was in the field of test design and optimization of electronic controls, where he was responsible for the software development of the product Cameo. Horst has held the position of Global Research Program Manager in the Central Research Department at AVL Instrumentation and Test Systems since 2010, and has established and managed several research projects in the field of electrified and automated driving. Moving back to the virtual world, but really there, that's Dr. Simon Edwards. Simon, there we go. Dr. Simon Edwards. Simon has been working in the automotive industry for almost as long as I have. 35 years. Nice one.
1984, Andy.
And you worked at an OEM, a Tier 1, and an RTO. And you are currently Global Director of Technology at RICARDO, based in Germany. Simon's responsibilities include the government-funded research portfolio. Simon is a co-author of over 40 papers, a co-editor of 2 books on statistics, and has been on the organizing committee of conferences around the world. He's a vice chairman of AirTrack, and the immediate past chairman of EARPA. I'm not quite sure how you even say it, but it sounds fantastic. ERPA.
ERPA. Yeah.
Okay, there you go. It's obvious. And he's also been a visiting lecturer and is a member of the advisory board for Esslingen University of Applied Sciences in Germany. We also have Dr. Engineer Philippe Desprez. Philippe,
yes,
there
hello.
we go.
You again.
Philippe, you graduated from NSIC, that's the National High School for Chemical Engineering, in 1991 with a PhD in process engineering. Philippe was a research engineer for battery electrochemistry at Alcatel-Lucent from 1997 to 1999, and you joined SAFT in 1999 to start work on battery and supercapacitor systems. You led the SAFT Research Battery Management and Modeling Group at SAFT Corporate Research Center for 12 years, and you have been granted more than 16 patent families, and you are the SAFT Senior Expert. You've been a modeling expert at SAFT's solid-state battery program since 2018, and you are the coordinator of the demo-based project. Next up, we have Dr. Engineer Jens Ewald. Jens, there we are, I can see there. Yeah. Jens graduated in mechanical engineering and energy technology from the University in Aachen, Germany in 1999, and gained a PhD at Aachen University in 2006 on simulation and modeling. He has held several technical positions in simulation at FEV, and since 2016 has held the position of Senior Project Manager for ICE engine development and vehicle calibration. Jens is currently the coordinator for both Hi-Fi Elements and the Sublime Battery Research Project. Jens has published several publications on combustion theory, ICE fluid simulation, and BEV simulation. That's everyone except Maurizio, and I'll introduce Maurizio when he appears. Okay, round table. I'd like to start off with a warm-up question, maybe on my screen left to right. So Simon, if I can start with you. I would like to, yeah, typical, the first one, thanks. Yeah. But could you give me the 2 insights, the 2 most important insights that you gained from today? What struck you? What have you said, this is the way forward, this is new, this is what we have to do, this needs looking at? 2 things.
Thanks, Andy. Give me a moment, first of all. I haven't presented yet today. I'm not going to present, but first of all, congratulations and thank you to all of the presenters and all the members of the various consortia. Excellent piece of work, and it's been a good day so far. But with those words, just let me think about it for a moment. Two things stuck in my mind. One was first of all, the overall headline savings. They're great set of overall results that we've got. But the comprehensive nature of some of the simulation that's being done, the number of different vehicle architectures, and the number of different methods that are being applied, it really is a great bloom and boom for where we were for 3-4 years ago. So that's one of the things that stuck in my mind. And then also I'm pleased to see that some of the dreams that we had when we were setting up these projects along the lines of the real-time interaction between the hardware, the components, and the software and the simulation. So simulation, control, and hardware, all interacting together and giving us some good results. That's the second highlight for me. I'm really pleased to see that as well.
Okay, the boom and bloom and dreams come true. What a start. Okay, moving across, Jens, what are your two major takeaways from today?
Yeah, I think one of the things we have to think of, how to do the transition, not only from the technological development, but also take, the people with us who had worked in ICE development in the past, and maybe on so many people we won't need anymore, and we have to do the transition, to the new technologies. So maybe it's just that, but it could be the hybrid. So these are the two things that I'm thinking of, and myself, coming from a CFD background and doing things like internal combustion engine simulation. So I see lots of parallelism between what we did for the ICE and what we can do for battery nowadays. I think we have a really a big resource and people who have in-depth knowledge of this, and we can do the transition from the one to the other. Yeah.
Okay, so yours is transition. First of all, it's the transition itself. It's exciting. And the second one is you're saying you can see a certain parallelism between the ICE expertise that you have and these new things. Okay. Okay, so maybe these things aren't as new as we thought.
A burning battery, very similar to a burning combustion engine. That's what you said already, yeah?
Yeah, well, what's the difference, yeah?
What's the difference? I mean, many years ago, I had a discussion with the astrophysicists. They say, the supernova explosion is just the same as the combustion, an internal combustion engine, the same, characteristic numbers. So I see some parallelisms here as well,
Okay, thank you. Philippe, what are the two major takeaways that you have from today?
The takeaway is really now the very fine-tuning on all the seamless process which are performed by simulation on the coverage. It's very impressive how we can go from mill to seal and to integrate new components. And so it's now something which is implemented, and it's very efficient. And I think that it's something which will push the future generation of vehicles which are coming, and it's a great advancement.
The simulated process, so you mean not the actual simulation, the fact that this has become not just a point of simulation, but a whole process now. Is that what you mean?
Yes, I have a lot of background.
Yeah, there's a lot of background noise at the moment, yeah. We're not sure where it comes from.
Yes, that's the point, that simulation is not, I would say, an activity alone, but now it's really integrated together to have the whole picture of the vehicle, and you can go deeply, depending on your expertise, depending on your job, in some points. So you can go further. If you can go further, you can go further to conception, and you can go deeper. But really, it's a quite strong to have all these integrated tools which can be used by in Europe, I would say, by stakeholders.
Okay, Matthias, could we have your views, please? The two major takeaways from today.
Yeah, well, I only was participating partially there, but I very much agree with what Jens was saying. So that's also my experience, that there is this whole transition is not only a transition of the industry, it's also the transition of skill sets that are very useful also from other technologies into this technology. And I could see that in my time when I was at fuel cells. So there was CFD simulation. There was also a big thing. And we took also a lot of things when I was transitioning from fuel cells into battery development. There were also a lot of similarities that we could take with us. So I think it's an extension of skill sets that need to be taken together. And I think from a simulation-based development, there is still a lot of potential that can, on the one hand, enable development and new findings, but also ensure that the whole development process is much more, it's much faster, and maybe some of the hardware phases can be left out. So for me, very important that this is an integral part, an even more integral part in the development of new systems and technologies. So for me, very important that then the consequence really also is to relieve then hardware phases and really bank much more also on simulation and virtual development. So that is for me very important.
Yeah. Okay, so this front-loading idea, changing the V cycle into a line, who knows? Okay, we'll talk about that in a moment, yeah. Thank you very much, Matthias. Horst, can I have your view?
Yes.
2 major takeaways, please.
Okay, there was really a lot, actually, and I made my notes. It was very, very interesting to see already at the beginning Matthias' view from the keynote, actually, that the different technologies are competing with each other, that there are advantages on the one side, disadvantage on the other hand side. So there is no decision, there's no clear decision until yet. But you said also future is renewable, net zero, and electric. So I think we all agree on that direction. So that means it goes in the direction of electric. However, this will happen with which configurations. And for that different configurations and for the exploration of that, we need the simulation techniques that we have shown today. We have, I think all projects have made huge steps forward in this direction. So we are able today to, on a much more detailed level, to do the simulation and therefore to do much better assessment of the vehicle and the decisions that we need there. And one thing that impressed me also very much, that we have these complementary topics that we have presented today, but all going in the same direction. So I like that very much.
Okay, I'd like to go around now. I'd like to call this section the technology section. I'd like to go around in a round robin with a few hopefully provocative questions. And if you feel like you need to say something, that's wonderful. Stop me, say something, stop the speaker. Let's get a bit of emotion going because it's better to watch. So let's start maybe with Horst. And the first provocative question for you. Your homepage says that Obelix addresses the urgent need for new tools to enable multi-level modeling, etc. What's so urgent? Why do we need new tools? What on earth is multi-level modeling?
Mm-hmm. Multi-level modeling, I think it came out during the presentations today that we need detailed modeling for instance, for chemical processes. We have to go on higher levels. We have to go for the battery cell, for the battery module, for the battery pack, for the vehicle. So that is one kind of level, actually, that was also seen today, or shown today. And also then different kind of models. Yeah? So we have 3D models, we have 1D models, we have models that are coming out of measurement. So I think the simulation is a very broad topic, actually, and we need still more of that, I would say, to cover the whole range.
Okay, and the homepage also says that your overall objective was to create this framework. Mm-hmm. Have you succeeded?
Definitely. I think we are not...
confident answer.
We are not at the end, but I think the tools that have been used throughout the projects and also the demonstrators that we had within Obelix, I think you've seen that there were huge progresses actually in that, and this was possible due to the developments within that tools and within that framework that forms actually everything together.
Okay. So Horst is fairly confident. Don't forget, you can interject at any time, gentlemen. In the meantime, let's see if we can provoke Jens into something. Jens, your homepage says that HiFi Elements will develop, validate, and publish a recommendation. I'm a pedantic semantic, so develop a recommendation. Okay, validate a recommendation. Not sure what that means. Publish a recommendation, gotcha. How do you validate a recommendation?
Well, let's start with the word recommendation, because we were, first of all, when I was, let's say, starting the project, I said, we are publishing a standard, and I was hit by INEA basically saying, you're not publishing a standard, you're publishing a recommendation for a standard. I think this is the important thing. We have a small development group within HiFi Elements, basically compared to, let's say, the whole community who's doing simulation, and they sat together and say, okay, how should a standard look like, So we are not an, ISO standardization, let's say, consortium, where we come up with, let's say, an ISO document where the standardization is. In HiFi Elements is really, let's say, a group of people who have worked together collaboratively, and we have published, let's say, this recommendation. So this is one of the things, yeah. And of course, by publishing the recommendation, probably saying, okay, we were, until that time playing in a sandbox. And that's the reason why the use cases now start and they're about to finalize, as you can see, that they validate the recommendations for the architectural and interface standards that we did. Seeing, does this really make sense? And if not, where would we have to make some adjustments? Yeah. And so this is what we have done, and we are about to finalize on that. And I think at the end, then we can say we have a validated recommendation of our standards. So this is basically the idea.
Yeah. What's the next step? So you have a recommendation, you reckon it's a good one. What's going to happen to it? Who's going to follow it?
Well, first of all, that's right. This is the good point. First of all, of course, I mean, we are like we are hatching this a little bit. Of course, there will be follow-up projects within the U, where we will where it will be further used. I can mention some names like the Sevolver project, like the Subtle project, and so on. They take the recommendations over with us. I mean, these are projects where there is a continuity in members starting from HiFi Elements towards those other projects. But of course, since we made this public, and I really can recommend everyone just to visit our homepage and download our publications there and try to and use it on your own. I mean, that's also what we did with Obelix. So we had these exchanges between with a group of Horst, with Obelix members and so on, and there was some adoption, of course, and people might have other ideas. Maybe they started off with a completely different conceptual thing of this, but now, of course, it needs to be like we will see whether it survives, and if other people also will think that this is worthwhile to continue to be used. Yeah.
May I step in here?
Yeah, please. This is what
because we have also some experience with standardization. A project is good for developing suggestion for standards, as mentioned now by you and also by Marina. And in order to make that available for a longer time, I think another project is just also a temporary stuff, but not a complete continuation. So if you find an organization, like for instance, I don't know, ASAM or other organization or Modelica,
yeah.
So if you find organizations that are willing to take over that, that's a much higher likelihood that this will really survive.
Right. In the meantime, we have Maurizio. You have a degree in aerospace engineering from Milano Polytechnic, 1985, nearly 1984. Then you joined Augusta, the Italian helicopter manufacturer. I'll just quickly go through this. You were in charge of a lot of EU-funded cooperative research projects. That must have interested you because you moved on, and now you are in the Directorate General for Research and Innovation, where you are involved in the technical content of road transport topics, and you work in several working groups on decarbonisation, fuels and pollution regulations. And you are responsible for IC powertrains, their after-treatment, hydrogen, fuel cells and light structures in the road sector. A busy man.
Yeah.
Can I ask you?
In the meantime, we had dropped some of the things because you know that now is colleagues like Marina taking care of part of the work, but yes, quite busy.
Well, here's a question for you then, your initial warm-up question. Marina said that there's an urgent need for new tools and methodologies. What is so urgent? if things are not that different, if we've had simulation forever, and we've had modeling forever, why is this urgent? What has changed?
We had a lot of simulation. We've been funding this in many areas. But it's projects like these are dealing with something which is still not fully integrated, I think, in the thinking of the companies on one hand, and at the same time, the kind of accuracy that we are getting in some areas. In other, I think that the work has been done an extension, has been to do an extension of what they've already done with combustion, and I think this is probably less critical, or in any case is more accurate than other areas. But you know, we've seen the simulation on batteries and things like that. You have, at the moment, you're calibrating chemistries that you know. I think there's a lot of areas which are to be continued and to be explored, because that's where we are lagging.
Maybe that's where I can bring in Philippe, because on one of your slides, Philippe, you mentioned, I think it was the third slide, massive digitalization. Massive, not a little bit, massive. And in your PowerPoint, I didn't see any. And here we just heard there is an urgent need for this. What am I missing?
Okay, you miss nothing. It was for the discussion I keep the information, but you see the presentation of Martin and the colleagues, so no problem. Yes, massive digitization is needed, especially on the battery side. We have spoken about battery side. And today we have, I would say, average model. We can call like that. We can have a reduced model, but even when we have spoken about deep model, electrochemistry, things like that, it is based on average model. So you have a lot of research to go beyond this model and things like that. And the point is that it's not like engine. It is as complicated, maybe more, maybe less, I don't know. Maybe the problem is nearly the same, but we don't have the same maturity at all. That means that many people are not confident still today on the model you can develop on batteries. Of course, electrical model, it's okay, but when you want to go deeper to see, okay, what will be the behavior, how you manage the fast charge, how should be the material behavior, the mechanical characteristic of the materials, all this stuff is not still covered, I would say, at a mature level, which is enough so that we can design the battery by simulation, so we can have a good control of what we do. We are not still in physics. We are still a lot of scenario more in, let's say, like in chemistry and like in medicine, where it is done by experiments. Of course, it's very good. Chemist, it is my best ground. But nevertheless, sure that each time you manage to have a good fidelity when you model topics, materials or a battery or a system, you make a large improvement. Because then you can fine-tune, you can design your system, you can go deeper to the properties you need. So it is a urge improvement each time you manage to cover another topic by simulation. So that's why we need massive digitalization, and we have to go up to the end. That means not to stay at the part level, but we have to go to the system. And I think it has been really well presented today, that now you have seamless process which cover all up to the vehicle level. So it's very good to have this possibility to go from the parts, I would say, to the global
massive
system.
digitalization. Okay, I'm with you. I need to move on. There's two questions here. One, Alain, if you're listening, I'll ask it in a moment. It's a cool question. The other one from Willem is immediate. Maurizio, you said the thinking from projects is not yet integrated in industry. So what does it take to fully integrate it? Who needs to take the next step to get all these innovations implemented? What is the next step? There are three questions in one. How's that?
Well, if I can elaborate, let's say, on the last discussion, the problem is that we have items like the cells where we just heard the maturity is less. The the problem is that the cell is exactly where we are lagging, and we need to catch up. So on one end, there is this need to push on this pedal to try and do this catch-up work. At the same time, I am not an expert myself, but I talk to people. Just this morning, I was on the phone with one OEM representative. We were discussing batteries, and he said, if I ask, you know, the life of the cell, everybody's talking about second life. I asked a lot of people, and basically, everybody can say more or less what happens up to 80%. And then he said, when I ask, okay, but what happens afterwards? When it really dies, why, how can I, you know, assess the value, for instance, of a second life cell? Or simply, in my view, 80% is this kind of magic number, but I'm using a lot of stuff.
I'll come back to you, because there was 3 parts to the question, and the first 2 parts were missing. But Simon wanted to say something, if I saw that message correctly.
I didn't want to interrupt Maurizio. I was waiting until the 3 parts of the question had been answered. But I was going to respond to what you said, Maurizio, implied in the question about the use of what we've learned in these projects. I mean, okay, RICARDO are relatively early in the food chain. We take things straight from research, if you like, and then we use them as an RTO directly with our customers. And that's actually what we're doing with the results, for example, of Hi-Fi. We've already applied what we've learned directly onto commercial projects. And whilst that might be a little bit away from actual products, it's business for us already. It's business that I know then our clients will take and use themselves next time round. So it's a hard business as well, but we really do benefit from these sorts of projects.
You can basically jump this step because you have a direct link. I think in the industry, there's a lot of, basically, a lot of the people which are there are not from this sector, don't have probably so I see a little bit more skepticism, let's put it like that. On how to transfer this. This is my feeling, as I say. But I asked this question this morning, and he said, we don't know. And he's someone who already knows, he's been in the business on the electric part for some time. But of course, probably when he has to go to his boss and explain it, he has problems. I don't know.
I think,
Horst.
Can I also comment on that? Because I started in the automotive industry in 1995, as Andy mentioned before. And when I started, I studied electrical engineering, so I had no clue about combustion engine. And I learned there, okay, the combustion engine has a few variation parameters at the time. This was 3-4 parameters, not more. And over the next 20 years, actually, they grow more and more. And now we have 10, 12 parameters, or even more, up to 20 parameters in the combustion engine that can be changed, starting from the, you know, all that stuff I don't have to tell you, combustion timing and inlet, outlet, air, whatever. And the combustion engine was always the center part, actually, of all discussions, at least how I saw it. It might be also be associated with the company, but this was really what has driven actually the progress. And now, if I look at the electrification, I have now, I think, a very good overview. Maybe not all the details, but the battery itself is at least as complex as the whole combustion engine. Yeah, you can talk weeks and months about all the details about the battery. And we have mentioned that today already very often. But I want to point out the inverter. If you go to the inverter, then there's so much actually what you can do there. You can go down to the semiconductor level. You can talk about switching frequency on the lowest level. You have half bridges that have to do the right timing, that have the right timing. You need sensors to measure their.
Well, this is the complexity.
But I wanted to give some examples, actually, that you know what I'm talking about, or everybody here, I'm sure you do. the e-motor, it's exactly the same.
I want to get back to the question, because that's the complexity issue.
And this is the different, actually, topics which, if I talk about the inverter and the battery, these are completely different experts. So we have battery experts, we have inverter experts, we have e-motor experts, we have to put that together. And then maybe there's also the interaction with the combustion engine also. So it's an extremely complex topic, although everybody's saying electrical vehicles are so simple.
So if I want to summarize this, Horst, are we saying that, because the question was quite simple, the statement was from Maurizio, the thinking from projects is not yet integrated in the industry, okay? It's not. The question was, what does it take to fully integrate it? From Simon, we hear there are moves, but from an RTO. So the RTO is agile, takes new ideas. We're not yet at the product level, but you are talking to people in the production world. Presumably they just do not speak your language. Point one. And then we've got Horst saying it's interdisciplinary and no one understands each other either. Plus it's all new. How are we going to, that's the question. How are we going to integrate this if we have an interdisciplinary problem, a complexity problem, and an industry language problem? Gentlemen. Simon, yes, smiling. Come on, someone answer.
I can start a proposal, let's say. But sure, and it is the beauty of simulation. It is not when you have to go precisely on a question, because human brain can do it. But when you have many multi interaction, we have a lot of difficulties to integrate everything in our brain. And so I think that simulation is very useful to integrate all this complexity. Each one is not maybe so much difficult for one expert, but it is not compressible by another one. On making it using a common language with this simulation, the language on the schematics we are using, it allows to have a communication on the right level for all the people involved in the project. That's why this mapping with simulation can provide an overview from the expert to the management, so that you can drive the evolution in a company. Because of course you have to make sure so that everybody want to join the project and would want to take the risk, which has not to be a risk.
So you're saying that one of the methods to combat complexity is simulation, makes it easily understandable for everyone because they can see their part of the big picture. Simon, Jens, and Horst have to do a top-down messianic approach because they're the RTOs. They have to move things down towards the production guys who are not interested in change. And Maurizio is waiting for results. So that kind of closes that chapter. I have another question. Alain has asked a question. He says, it seems easy to estimate the reduction of energy consumption of a new battery electric vehicle, but how do you estimate the reduction of the development time of a new vehicle?
Yes, so it is for me, I think. Yes, development time, we can measure it, especially, we are working in the scope of our project. That means on some highlights, for example, for stamping for a vehicle. So we know from our expert from IFEVs that we can have a very long development time when you have to make stamping and to create a new platform. So we have some information on in such information we have the state of the art, and we make a proposal. For the chemistry, same thing. We know that to qualify a cell is very long because, as been said, it is very unpredictable. After 80% what happens, and you have to know what happens, so it takes time. So we know something, the state of the art, and then we in the project we catch a shorter time as an objective, and we assess what are the results. So in some specific topics we are able to do it because we have the experts in the program.
Okay, I've got one more question concerning battery cells, and then I want to move on to Matthias and Simon. I'll just move this. This question comes from Pietro, and he says, a cell is a living creature, but nobody has shown how it breathes. It seems they all got COVID-19. If you consider a cell a static element, the simulation of a battery pack has little value or no value at all. Are we simulating the wrong things? Are we simulating too small? I presume that's what Pietro's saying. You simulate something small and you lose sight of the big picture. Have we done that? Is that a mistake?
Yes, yes. We know that point, but it is a key point. We know now that you do not cycle a cell. You cycle a cell in the frame of a module or with the same constraints. We know that we have a relationship between the mechanical constraints of a cell and the behavior of the cell. So these things are known on I would say used in the different companies, but of course, now what I already said, that I think now we say that today we shouldn't see now in future European funding projects, things like that, to have tested cells by themselves. But you have to have a context and to take into account the mechanical constraints. And maybe it will be also a field of research to go deeper in this way.
Maybe I can also make some comment on that. Because we are seeing always the same questions again. It's like, you guys from the simulation, what you're simulating, it doesn't really match reality. This is always the same thing that comes up. It's, regardless of if you're talking about mechanical durability, about, let's say, fluid turbines modeling, combustion modeling, whatever. And now you're talking, I hear the same thing again when it comes to batteries now. But I want to make one point, and that is that simulation also helps you. It's, let's say, your incentive to put, let's say, your testing results into, let's say, a contextual background, into the same one. When you start, let's say, if you have lots of testing results and try to, let's say, model them at the same time to see how the correlation is, then the people start to understand maybe what are the mechanisms which are behind this, because these are the mechanisms that you want to put in your simulation model. And once you understand, okay, now I have the best correlation between the two, then you think you really have the physical understanding of this.
Okay, so you're saying that there is a danger.
Unless you do the modeling, that's what I want to say. You don't understand what is really going on in terms of the physics. So this is what we should keep in mind, where also simulation is good for, next to the prediction of further developments.
Okay, so you're saying simulating at a low level does have value. It might be dangerous to extrapolate too much, but it has value in creating a context for the next steps.
For me, I would like to make it like this. Maybe you can see my screen now. I would like to climb up like a hill. In the very beginning, you don't know anything. You're just there at the bottom of the hill, and you start to learn. The more you do simulation and modeling, you are climbing up the hill, and at the end, you are at the top of the hill, because you have to start to understand what is going on. So this is what you're saying. The deepest background of everything, and then you see, okay, how much can I simplify now, and what is really relevant, and then you're going down the hill, and then when you just have crossed the whole mountain, you will understand, now I know what is going on. Maybe you don't have to do everything on the low level, but now you are back on the macroscopic level, because you really have understood the most important relationships. And this is a very, let's say, generic thing, and I see this all the time coming up, regardless of what discipline we are talking about.
Okay, in terms of modeling, I'm going to ask you a question in a moment, Simon, and Matthias, you're next. Simon, is modeling precise enough to be able to eliminate parts of the development cycle and really reduce prototypes? Are we there? Have we finished? This is it. We finally eliminated the V cycle, and we have a one-button simulate and model everything environment. Job done.
Andy, you're as provocatively phrasing the question. I know it's been a very good discussion inside of RICARDO as well about this point. And I tend to get closer to your position than maybe some of my colleagues who have to do the actual engineering work more often than I do. However, realistically, modeling and simulation has improved significantly, and it is a great means to enable the communication between the different divisions inside of the engineering group. It's got so far now that we are, again, thinking about, for example, projects that you might call delete A. We're trying to get rid of A sample prototypes so that we can because in simulation and modeling, we can compare a bigger domain and get closer to the optimum without initial testing. So yes, it is bringing benefits like that already. Is it precise enough? It will always get more precise, and there will always be people who say it should be more precise. But from my perspective, in the, let's say, the limited product development domain, it is precise enough to already help along those lines. You can ask me another question, Andy, later about how we go on from product development to business change to regulation change. And I think there are many more things that modeling and simulation can do to help us assess, measure, and decide. That's another point.
Interesting. Okay, so you're saying it's good enough, precise enough for decision making, and perhaps even good enough for a delete A. The rest is an exciting to do.
Exactly, yes.
Okay. Matthias, here's a question. I was reading LinkedIn the other day, and Herbert Diess replied to Bill Gates, see how well connected I am, at least through LinkedIn. And Herbert Diess, so CEO of VW, said that cars and delivery vans will be electric. He said long haul will use bio or e-fuels, ships and trains, fuel cell. Sorted. What's the problem? Everything's clear.
Yeah, I think the future scenarios can maybe look that way. So, but right now, all these projections are just scenarios in my eyes. I think when you think about an application map, so I think this is what typically is used by the industry, by the OEMs, so that they see what usage profile do you have, what application do you have, heavy duty, high performance, maybe also usage pattern in one area. So there are a lot of questions and discussions about then what power do you need, what energy density you might also need then for maybe driving very long distances, maybe that that are not the same all the time. So you need to have very individual then refilling or refueling or recharging opportunities. So I think that all brings it into context when you think about kind of the long term, and I tried to address that a little bit with the speech this morning, is you need to be very responsible with the use of energy overall, and I think so in the end it might not only be the question, is a fast refilling or recharging best, or is maybe the most efficient way of using your energy the best, and for sure with energy density going into a heavy duty truck with a lot of power demands, yes, synthetic fuel makes sense. Also, when you think about airplanes with long distance travel from intercontinental flights, probably very similar. So when a battery becomes then too big, too heavy for the demand that the application needs, probably not meaningful, and there is the space for fuel cell. Fuel cell still is struggling there a lot with heat rejection. The delta T to the environment is not so big. So with big power, you also need to have big surfaces that also has its limits. So my answer is not straightforward. The answer is diverse. So, but there's a lot to do, and the statement is not wrong, but also cannot be proven yet.
Here's a question for you, Maurizio. I don't know if you're the right one for this question, but if Horst was saying before things are complex, things are interdisciplinary, Matthias just said the future is uncertain, even the technology mix is uncertain. We've got Jens and Simon and Philippe saying RTOs, production people aren't even here. And the poor students, how do they know what to study? Are we actually training our young people the right things to cope with all this?
Yeah, you're touching something which is really close to my heart, because I see a lot of questions about that. And you talk about students. I think the whole chain has to be looked at, because also the guy in the workshop repairing your vehicle probably needs a quite different set of competencies with these developments. So on one end, what we do is funding projects like this, which I'm sure have had a kind of training effect on many young people. So, of course, we cannot go and ask the parliament, give me billions to train young people, but it's one of the benefits, for sure. And at the same time, I think we have all these uncertainties, and my way, maybe as an engineer, maybe a bit simplistic, but I try to look what I have. And what I have is some technologies that are perfectly, almost perfectly known in all aspects, benefits and problems. And there I hear about, for instance, alternative fuels and so on. The problem there is that the technology the engine is there, the fuels are very far from being there. You know, when I hear about synthetic fuels, I think, okay, you need, first of all, you need the electricity, because another of the gray areas is what hydrogen are we talking about? If we talk about green hydrogen, then you need lots of electricity. And then you have to set up huge electrolyzers, which at the moment we are not at that scale to get the hydrogen cheap enough. And then you have to set up the plants that do that and transform this into natural gas and then a liquid fuel. And in doing that, by the way, you need a lot of water, which is not in the places where you would do the energy. So also this needs to be discussed. And I had, there was a conference at the European Parliament, and the most optimistic people from synthetic fuels were saying 2040, 2050 to get a similar cost to the current fuels. Now, if I look at this, I say, you know, when I have nothing else, I would go this way. But otherwise, I would try something that shortens this chain. Yeah. So I would say that hydrogen is my, let's say, next best, because it doesn't need some of the other steps. But still, even there, we are not there. We need to do a lot of work to scale up.
Simon raised his hand. You want to say something?
Sorry, yes, complementary to what Maurizio has just said, actually in relation to your question about training, etc., and specifically in relation to this area that we're talking about. We've all been through, we're going through a lockdown. One of the things that happened in the UK was that the Institute of Digital Engineering took advantage of this and gave a week-long session of webinars on the latest findings from projects a little bit like Hi-Fi, all in relation to digital engineering and what the benefits are there from that. So that really helped us all learn about what had been going on. The Institute of Digital Engineering were also very clever, and this is where I was thinking about Maurizio, because they effectively gave us a week-long training on the state of the art. 2 weeks later, they then offered a call for future research, exactly having said what the state of the art is through training us all. So there's a good practice there, I think, to adopt as well.
Okay, thanks for the feedback. I've got a question for Jens and Matthias. Maybe start with Matthias. All this research, modeling, simulation, front-loading, V-cycles getting thinner and thinner. Do we need a V-cycle?
Well, I think we discussed that a little bit earlier. So I think the logic in the V-cycle still makes sense as it comes from a conceptual level going down to an integration level and to a validation level. I think this is still good. When you think about hardware loops that we need, that I also said that earlier, and others said that also earlier, I think there is big potential to reduce. And it's for me just a balancing of risk. So when you leave out some of the hardware loops that you might integrate and have, I think some people also think about the V cycle having little V's along the V cycle that all iterate back and compare requirements and with little hardware steps. I would also say, yes, this still is a good thought model, but the balancing, if we maybe go not too much in prototypes, go directly into maybe series tools, produce very serious close hardware, making with those a validation loop. This is also possible, and that kind of closes the gap then a little bit more to simulation directly there. But then when you then run into an issue, your recovery cost then within your development process might be a little bit more expensive, but maybe in other projects you gain a lot. So this is, I think, the kind of balance that you're looking for. And therefore, I don't see the V-cycle logic is not obsolete. I think this is still good.
Okay, Jens, what's your view
I
on this?
I would basically also agree to what Matthias said. So that means, of course, we have to have a straightforward procedure here. I think iterative activities will always mean that you're doing lots of loops and you're trying to reduce them somehow. But let's say the V cycle itself, it will be, let's say, a tiny V cycle in the very beginning where you make very small loops according to the V cycle in the very beginning, especially, let's say, what definition of requirements and so on is concerned. And if you reuse lots of your technology and your components in future projects, you can also then at the end reduce, let's say, the validation, so the other part of the V. But in general, you try to have it still, try to introduce, let's say, lots of digital methods that do validation in between in an agile way, as long as no physical tests are concerned. And once, once you are finished with the digital part, you try to be as straightforward as you can still.
Okay, we've got 6 minutes left. There's still a few things I'd like to ask you all. I'll throw this one into the virtual forum and see who starts talking first. Where are we compared to the US and China? Simon, I'm talking about the Europeans. Ha ha.
Maybe I try to make a comment as I thought I made the comment a little earlier because that already did fit into the discussion. What I'm seeing, for instance, in China with a lot of the industry partners there, and I also see that with newcomers into the business, their expectation into development times and their willingness to take risks and maybe going with some not completely validated products into the field is different than we have it in Europe with a lot of traditional approaches. And that makes it difficult. That I also is a little bit in the way of making aggressive new technology approach. So this is what I'm seeing as a comparison, and that always makes it a little difficult for our competitiveness and brings us a little bit behind there in some of these aspects.
So you think? Sorry, Maurizio.
No, it's just compliment. I mean, I guess I think we should limit the discussion to where are they in this kind of domain. So how good are they at simulating, and therefore but I would also highlight another thing, which was a personal experience last time I went to China. For understanding the battery, they maybe have modeling and simulation, but they made sure under government control to have someone who's collecting the data second by second, I think, or 10 seconds by 10 seconds, of everything that goes into the cell, into the battery, for all electric vehicles in China. So I think that there is also this dimension, which is learning from the field, which with this kind of methodologies probably give you a lot of insight. And I'm not aware, for sure not at government level as in China. The Chinese have given, I think they divided the country in a few groups, in a few areas, and in each area there is someone who's responsible for this database. And then they have it for use by the people that need to understand how to improve. So we have modeling and simulation on one hand, but closing the loop with the real data, it's also something which is interesting. And this, as far as I know, the Chinese have it, the Americans partially have it, because UC Davis has a contract for the US government for collecting data, but I don't think it at this depth, but I might be wrong. And I don't know exactly what is happening at member state level, for sure not EU level.
Okay, Philippe.
Yes, I just wanted to add all the simulation activity, modeling activity we perform, it not has to be an additional step in our development. It has to, as had been said before, it has to be used to save time and to suppress some steps of development, hardware development. So to foster the development, we really have to take care that when we implement simulation activities in a company or anywhere, we are the counterpart that we suppress some other activities so that we have a global gain or reduction of development time, not an additional activity.
I've just noticed the time. I could talk for another 3 hours. This is really interesting, but I need to keep to the timetable, unfortunately. 2 minutes left. I'd like to ask you all, maybe starting with Horst, what is the most important next step? So I'll start with Horst, and then I'll move around. Mm-hmm. Horst, what is the most important next step?
Yeah. Good. From my perspective, I've seen that we made a lot of progress actually in modeling. We have much better models. We have much more understanding about all level of details, and as requested actually by Ellen or questioned actually, we have to bring that into our vehicles actually. So the current state of the art or the new state of the art that we have to take that and bring it into the next vehicles, into the next generation vehicles. And I want to add one thing here. The nature of the human being is always expanding actually. As soon as we have reached a certain level, we go to the next level. So that means the production or the serious development shall use what we have developed, and we, with the research project, we try to get the next level. I think that's the nature that we have.
Super, thank you very much. I'll go around my screen clockwise, which means that Simon is next, and then Jens. So Simon.
Okay, thank you. I'll give you a step, stretch, leap answer then for what we need next. The step is that what we've done today with EVs, we should be doing tomorrow in relation to hydrogen fuel cell electric vehicle powertrains. So we should immediately take what we've learned and apply it to the next set of powertrains. The stretch is that we should take what we've learned about the vehicle modeling and then move it into modeling the vehicle in a road transport system. So the same sorts of things, but considering the complete road transport system. We've touched on it a bit, but we should go further with that, because without that stretch, we won't be able to make the leap. And the leap is very brave, but finally, I think we should be thinking about what we've done here and now and moving it on towards thinking about the vehicle in a road transport system in a circular economy. So really thinking about the life cycle effects, not just the efficient powertrain effects. It's touching on what quite a few people have seen there, but I'd like to see a simulation where I get a life cycle ohmmeter replacing my speedometer in my vehicle and telling me how well we're doing from a complete societal and industry basis going forward.
What a great idea. Okay, thank you. Jens, and Matthias is next.
Well, for the next steps, the immediate next steps, let's say, I would see is that we combine the findings that we have here for the BIF with the combustion engine again, because this is where I see for the next, let's say, next 5, 6, 7 years, we can have the biggest leverage. Just we know, let's say, an ICE engine is complex. We are starting to understand the complexity of BEV, but if you just combine both together, it's like complexity squared, because two different disciplines go, and it does not only double the complexity. The reason for this is because personally, when I was thinking of hydrogen, for example, I was thinking, do we really think that this will be in an immediate way going into the passenger vehicle? Because once we are creating hydrogen in a green way, I would think it will be probably used directly, in other sectors of our industry where, where hydrogen currently are being used, but as gray hydrogen. So maybe we would think that people will be having a car which will be let's say fueled with green electricity on the one hand, but for the long haul it still be the conventional diesel or gasoline fuel. So this is where I see where we should do something. Of course, it is not really the strategy we can do in the long term. Then we have to replace this against something else. But I mean, it would already help us just also to have the feel for the BEV vehicle on the long term, because in order to make sure that we have CO2 reduction, we need lots of other things like electrical infrastructure, hydrogen infrastructure. So it would help us just let's say to introduce these technologies as a bridge technology for the future.
Great, thank you, Jens. Matthias, you're next, and afterwards then Philippe. Matthias.
Yeah, so I mentioned already, I think for me very important that we bring the effort within the development down, so make sure that robust virtual development really replaces some of the hardware cycles, so really faster development cycles, bring the costs down of the development effort. I think this is very important. Overall, I think it's also important because there will be a mix of technologies for quite some time. I think this is very obvious. There is no clear decision, no clear pathway, and therefore it's important to stay technology open, I think, which is very clear, bring efficiency up, bring energy density up, and bring very significantly the costs down. I think this will bring best push for the technology, and it's very much needed.
Thank you very much. Thank you, Matthias. Okay, Philippe, and then Maurizio, you're next. Philippe.
Yes, thank you. Not so easy to be at the end to find new ideas, but I take the challenge. Yes, for me, what is the next step on what is what we should perform is to go deeper in terms of simulation of the process, because a product is not only a bill of material, but it includes also the way you produce it. So for me, next step can be to integrate process simulation to characteristic on the final product.
Super. Thank you very much. Maurizio, final words.
Yeah. Well, I don't want to add much also because in the end, it's all the gentlemen who are here that are actually to do it. And I think that touched on a lot of areas. So from my side, I can only say that the integration of these results is the most important thing to try and catch up in some areas and to maintain the lead in other areas, because in some areas I know the Chinese are buying European components in the top of their brands, for instance. So I think we need to use these as a leverage to achieve our strategic targets.
Great. Thank you very much. Well, that's it. That concludes the joint final event.